load ko dating ME ko. Yung C++ pa siya.
Yeah. And so, if nabalitaan nyo man, yung mga offerings ng one-to-one before ay C++ and naging Python ngayon. So, this was to address yung since hindi face-to-face classes and shortened yung timeline, tinanggal na namin yung part na magtuturo ng C++ and go straight into the core ng one-to-one. Kasi actually before ang syntax ng C++ hindi man siya part ng major requirements. Eh. Parang nasa exercises lang. So, and then yung ano rin naman is yung kailangan lang naman sa C++ mostly is yung magiging syntax. Yung basic syntax niya lang naman for your future subjects. So, kayang-kaya yun naman dapat siguro daanan yung syntax na yun through other means or baka kami rin mag-release kami ng yan, parang bridging program na for C++. Ang kailangan nyo lang naman is hanggang branching statements tsaka loops eh. So, yung OOP ng C++, hindi na natin kailangan daanan. Or hindi nyo pala kailangan daanan. So, nasa sa inyo na lang yun if kailangan nyo pa. Anyway, so for week 2, ayun, for any week, always start with the study guide. So, ang objective for the week is to study yung big O notation. And ano nga ba yung big O notation? What does it mean to, or how does it relate to runtime complexity? And calculating yung big O for functions in general. Tapos meron ng, kasi sorting is a very popular, I guess, popular problem. Sorting a list na marami ng well-known solutions or well-known algorithms. Maganda siyang point for us to analyze yung mga sorting algorithms na to in order to apply yung uh, analysis or as a good exercise for algorithm analysis. So, sa mga nandito ngayon, need nyo ba ng parang review ng exercises ng previous weeks or diretso na tayo for this week? Hindi ko or sige. Wala nag-reply so for last week, ang exercises nyo lang naman are 3. So for this one, guessing game, ano lang naman siya. Basically, merong isang number na important na kailangan mahulaan. And then you will be given a file. Okay. So the first line is an integer n, or the number of turns to play. So the second line is yung number na rows want Sam to guess. And then the following n lines contain yung guesses ni Sam. So, strange yung output nyo is, kuwari dito, ang input is 5, and then yung number ni Rose ay 34. So yung first guess ni Sam is 56, which is higher. So basically ako, kuwari nag-iisip ako ng number 34. Si Jose, gusto niya hulaan yung number na iniisip ko. Yung first guess niya is 56. So yung response ko sa kanya, the number I'm thinking of is something lower. And then yung next guess naman ni Jose will be 12. Sasabihin ko, since I'm thinking of a higher number, sasabihin ko higher. Then, ayun, pagka-guess niya ng 34, basically, nakuha niya na yung number na iniisip ko. Congratulations. So, ayun. Kuha na dito, 4 yung first number. And then, after 4 guesses, hindi niya pa rin nakuha yung sagot. Mag-output ng, sorry, better luck next time. So, I guess yung important lang naman dito is yung conditionals nyo, kung tama yung condition nyo. And then, dapat yung output nyo is exactly this phrase or this string. Kasi yung checker natin medyo meticulous. I think hindi siya case sensitive pa nga ata siya eh. So, dapat exactly ganito yung output to be able, to be considered correct yung checker.
I think skip tayo sa music lang. Kasi yan yung, I think yan yung nahihirapan ng mga tao.
Oh, tara.
Goofy siya eh.
For the music playlist, ayan, so basically, meron kang two classes, a track and a playlist. So a playlist is a list of tracks. So, of course, kung as a playlist, pwede tayong mag-add or remove ng tracks. Pwede natin i-view lahat ng tracks and pwede natin check yung total length ng tracks sa playlist. So, your task is twofold. You have to define yung playlist and yung so that yung my tunes is operational. And then, given a series of input tracks, create a track object for each one and add each track to the playlist. So, input is yung first yung number of tracks na i-add, which is ito. So, first 7, so we have 7 songs here. And then yung expected na output is i-remove yung nasa index 2 at saka yung nasa index 5 and then ipiprint yung output. So, I think yung isang pwedeng maging mali niya dito is yung indexing. So, remove 2 here is i-remove niya yung second na track doon sa list. So, hindi natin susundan yung zero indexing ng Python. So, kita nyo rin naman dito, the first track added is this first one, Mangarap Ka, by after image. Track number 1 siya. And then, magiging track number 2 yung Owl City, Dreams Don't Turn to Dust. And then, since na-remove natin siya through this line, ayun, wala na siya dun sa output natin. Then, same goes with this song over here. Siya yung pang 5. Yeah. So, yung another thing then is, nasa ko na yung notepad. So, pagka-set up nung playlist nyo, nakita nyo ba yun sa notepad? So, without the deletion, so supposedly nandito si Owl City. Tapos, 4, 5, 6. And then, yung song na to will be here. Tama ba? So, when I remove yung song number 2, so remove song number 2, which is yung line dito, mawawala itong line na to. And then yung track numbers should follow suit. So mag-a-adjust yung numbers. And then when I remove yung song number 5, ito na si song number 5 ngayon. And then, so whenever I remove yung item sa list, mag-a-adjust yung track number nila. And then, Tapos, ayun. Yung total duration, I guess yun, kukompute mo lang naman. So, so parang meron yata. Huwag niyo itong pansinin. Heh. Meron naman ng mga tapos sa inyo. So, I guess okay lang yun. Let's see. So, pag i-upload ko to, baka block out ko yun somehow. Okay. Ayan, yung calculation ng total duration. So, yung given dito is all in seconds. So, ito total, I guess, kailangan nyo na makuha yung total duration. So, from total number of seconds, kailangan yung format niya is hours, minutes, and then seconds. So, be sure to convert that properly. Then, next is debugging. Ito yung medyo nagka-problem kami with the with the precision. Kasi depende din sa formula na ginagamit nyo. Apparently, nag-iiba yung result ng rounding up and rounding down. So, ayun. If particularly sure kayo dun sa solution nyo dito, pero hindi tama yung lumilitaw sa checker, just let us know. Kasi especially when going from floating point numbers to integers, merong mga small details na nag-affect no out. Ayan. So those are your week 1 activities. Going back, si week 2, actually yung activities niya are all quizzes. Dalawang quizzes to actually in Udle. Although since si Udle is down right now, may kita nyo doon sa ating yung course pack, yung backup drive na binigay ko. So for week 2, you can see here 2 more PDFs na PDF version sila ng quiz. So pwede nyo na silang sagutan dito. And then pagka-up na ulit yung uli, or if we decide to go to another platform, ipa-plug in nyo na lang yung mga sagot nyo. And of course, hindi ko pa ma-discuss masyado yung questions dito. I can only show them. So, ayun. So, for big O, actually may small. So, for yung algorithm complexity, if kailangan nyo lang ng konting background, bakit siya ginagawa, why study algorithm analysis? Because yung ating hardware can only go so fast when may physical limitations siya. So, apparently lately, if we have a better algorithm, it's better than having a better na computer. Lalo na ngayon if medyo nagtitipid tayo, we can't buy supercomputers as regular consumers. Pero we want to process big data, for example. If we have a good enough algorithm, kaya natin mag-run on less powerful core. So, algorithm analysis is actually divided into 2 parts. So, yung first part ng analysis is the algorithm correct? And yun yung magiging focus ng next set of lectures actually. In the meantime, ang focus natin is how much resources does my algorithm need to run. In particular, ang tinitingnan natin ngayon is yung time. Ang memory naman is medyo trivial for now, pero in future examples, mapafactor in din natin yung memory usage ng ating analysis. And then, maganda rin tingnan natin yung resource requirement ng ating algorithms kasi usually meron tayong mga constraints doon sa algorithms natin. For example, if yung algorithm natin is magti-trigger siya ng emergency alarm, kailangan sobrang bilis niya. We can't, if there's an emergency situation, kailangan makapag-output tayo agad na result. Since yun, emergency, kailangan mag-run agad. And then may mga times naman na yung computer natin medyo mabagal or medyo limited yung resources, it doesn't have enough memory. So yung particular algorithm mo might cause your system to crash kasi kakainin niya lahat ng resources ng computer mo. So I guess medyo apparent na dapat na maganda tinitingnan natin yung algorithms na ginagamit natin. So, ayun nga, in terms of time, madaming factors na pwedeng mag-affect, hindi lang yung actual na algorithm mo. So, of course, a better CPU or more resources dun sa computer mo, mas mabilis probably yung magiging execution. And then, depende din sa programming languages mo. Kuwari, Python yung gamit mo compared to something C++, and then compared to something lower level, kuwari assembly, may different running times din yun. Kasi, for example, yung Python, dadaan siya ng interpreter. So, yung interpretation takes time. So, nagdadagdag tayo ng extra time dahil doon. Pero, for example, kung galing ka C++, compiled siya, yung compiled na code runs faster since hindi na siya dapat kailangan interpret. So, ayun. It also affects yung running time. And then, another thing, kumari yung coding efficiency na tinatawag, what if meron tayong extra lines for us to understand our code better? Usually, yung debug log or yung output natin na nilalagay natin, yung umabot ako sa point na to. So, may output ka doon sa terminal mo to make sure. So, yung mga extra steps na tinitake natin for that can add to the runtime of our algorithm. So, with these factors, kailangan natin ng way ma-analyze yung runtime without without being affected by these. So, kung gusto kasi natin ng better algorithm, dapat whichever computer ko siya gamitin, it will be better than another algorithm. For example, kung maganda yung algorithm ko pero pangit yung computer ko, mabagal yung actual runtime. Pero kailangan ko pa rin masabi, or paano ko masasabi na mas maganda yung algorithm ko if yung nag-hold back sa akin is yung CPU. So what is done is tinitingnan yung time complexity instead yung actual na running time. So time complexity, basically ang ginagawa natin, yung running time, we describe the running time with respect to the input size. So basically, gusto nating sabihin how much does the running time increase as my input size increases. So instead of looking at the actual na running time, ang tinitingnan natin is yung change in running time and how much yung pag-change na yun. So, yun, yung pros niya, less factors yung controlled, less factors yung mag-affect sa kanya. And then, yung mahirap lang dito is, what if hindi yung input size yung main na nagpapabagal ng algorithm mo? What if yung algorithm mo requires hardware na mabagal gumalaw and yun yung naglilimit ng running time mo? So yung time complexity na analysis, parang hindi na siya masyadong magka-factor in doon. Pero yun nga, as an example, kung paano tinitingnan yung time complexity, looking at this algorithm over here, ang ginagawa niya lang naman is tinstore niya sa isang variable, total, yung individual elements ng isang array. So, of course, pag dumami yung input ko, supposedly, mas tatagal yung pag-run ng program. Since more elements kay array, mas madaming elements ako i-add. So basically, mas maraming commands. So nag-increase siya. And then we describe yung increase as linear increase. Kasi, ayun, so from 100,000 na nasa 0.2 milliseconds, pag dinoble ko siya, halos dodoble din yung running time ko. And then pag dinoble ko pa siya ulit, almost mape-predict mo na doble yung running time. Then looking at this next algorithm, instead of adding lahat, ina-add niya lang yung first 10 na elements. And in this case, kahit dumami yung input ko, constant yung time niya kasi same number of operations pa rin ginagawa. So in this case, we describe yung time complexity nito as constant. So basically, whenever we change the input size, hindi nagbabago yung running time. Yung pag-compare naman ng running time, usually, we can actually compute yung running time. For example, dito, nakuha natin na we take n squared na operations for f of n. But for g of n, we take n squared minus n plus 2. Somehow nakuha natin expression na yan for the running time ng ating programs. Pag nag-zoom in tayo, we can see some differences. Pero pag nag-zoom out tayo, parang hindi na nagmamatter yung differences na yun. So, ang conclusion lang naman dito is yung highest, most increasing term lang yung nagmamatter for our, or we can just consider yung highest changing or highest, basta yung pinakamabilis lumaking term. Siya lang yung kailangan natin i-compare or i-take note. And then, yung coefficient din niya doesn't matter that much kasi it still follows the same shape. So parang, ayun, same lang din. So yun lang, basically yun lang yung kailangan natin pansinin. So yung highest growing term and then we can ignore yung coefficients. So yung algorithm natin can run at, depende dun sa input, it can run very fast or it can run very slowly. So usually, yun, so meron tayong cases. So may tinatawag na best case wherein pinakamabilis and then yung worst case kung pinakamabagal. And then may average case din naman. Tinitingnan lang natin for now would be your worst case. Kasi siya yung mas madaling i-assume. For the average case kasi you would need siguro parang statistics to say na yung case na yun is yung average. So, big O notation then yung other term natin for worst case analysis. And then, ngayon, basically, we present an upper bound doon sa time complexity natin. So, this is just a chart or graph nung commonly, or yung mga typical forms nung big O na function. So, of course, pinakamaganda, constant na running time algorithm. And then next yung logarithmic, and then linear. And at the worst, we have yung factorial. Almost halos vertical na siya. Excuse me. So to get these expressions, you usually start from counting yung operations na ginagawa ng program or yung algorithm. So your basic operations, usually, they are constant, yung assignment, operations, additions, etc. Then if nasa sequence sila or done one at a time, mag-add up lang sila. Now, ito, tatlong constant na operations, may O of 3. Pero since hindi nga natin pinapansin yung coefficient, we can say na O of 1 lang siya. Then, pag if-else na statements, we usually take into account na yung test and then whichever is bigger doon kay body 1 or body 2. Sa if or sa else, whichever is yung mas malaki. kasi kailangan lang naman natin yung highest drawing sa kanila. Pero yung test condition, lagi natin ginagawa. Kahit sa else tayo parating pupunta. Since kailangan mo rin naman siyang i-test. Basically, every time kailangan dumaan sa test condition. Kaya, andun siya at the start. So, usually, lumalaki lang naman yung running time natin when it comes to loops. So, for the loop, you just need to get yung running time nung nasa loob ng loop. Okay. You just need to get the running time doon sa loob ng loop and then multiply it with the number of iterations ng loop. So, in this case, is j is in range n. So, n times natin gagawin yung nasa loob na to. So, assuming na constant time ito, ang running time ng loop na to is O of n. Now, this loop is nasa loob siya ng outer loop na to. So, we multiply yung inner loop na to with the number of iterations ng outer loop to get yung pinaka-total natin na running time. So, O of n squared. So, some properties, pag nag-add tayo ng dalawang functions or dalawang running times, pag ginawa natin yung big O, we usually just get whichever is yung bigger term. So, kuwari n squared plus n, ang kailangan lang natin yung n. So, yung n squared. So, basically, parang nakaka-cancel out siya. And then, pag nag-multiply, multiply. So, and then remember, worst case yung big O. So, for example, here, yung innermost loop dito is k in range of j. Tapos j is in the range of I, and then si I sa range ng n. So, at the worst case, si k would be, or yung number of iterations dito, would be at most j. Then si j, at the worst case, would be at most I. And then si I, at the worst case, n. So, the number of times na magra-run yung loop na to at the worst case is n times. So, so basically, number of iterations na consider natin sa kanya is n. So, since k is j, j is I, I is n. So, so pag nag-rest up, may n cube. So, some limitations on the big O, since it is the worst case, and hindi naman pwedeng, worst case nga siya, so hindi naman siya probably yung parating nangyayari. So when we do worst case analysis, medyo ino-overestimate natin yung running time ng function natin. Which is okay lang. Lalo na kung if yung worst case ng ating algorithm is something manageable, and manageable na yung algorithm mo all throughout. So, pag maganda yung big O mo, maganda na yung algorithm mo. It can't get any worse than that. So, sa Discord, actually, nag-add ako nung exercises ko before. Kaso, ang problem lang is C++ sila. So, ayun. For this, to transition lang, yung for loop, ang main difference lang naman between C++ and Python is yung for loop. So, we can rewrite yung for loop na to as, hindi ko siya ma-edit. So, pwede kong i-hiwa-hiwalay yung contents ng for loop to look like something na nasa Python. Meron lang mga semicolon at saka parentheses. Or mauna yung So basically, yung for loop may tatlong arguments. Yung first argument is done before the loop starts. And then yung last argument is done when the loop, for after every iteration ng loop. And then yung nasa middle, siya yung condition ng loop. So basically, from I equals 0 to I less than x, magsa-sum plus plus. And then yung plus plus naman na to is the same as uh, sum plus equals 1. So, shortcut lang siya to auto-increment yung content si sum. So, easily yun dito sa loob is a constant na runtime. And then yung loop naman na to would be yung number of iterations, which is x, times yung runtime na nasa loob. Making O of x. Then, since alam naman natin yung other commands dito will just be constant, yung running time ng buong function natin will be O of x. Then, yung dito naman sa baba, yung running time nito is actually yung additional operation would be constant plus yung function call natin. So, yung time it takes for function 1 of I. But alam natin si function 1, ang running time niya is O of x. So we can replace this with O of I. And then si I at the worst case we know as x over 2. So since we don't care about yung coefficients, this will just be O of x. And that is just for the body ng loop natin. So yung actual running time ng loop is yung number of iterations, x over 2, times yung running time sa loob of x. So, removing the coefficients, this is just O of x squared. So, yeah, yung magiging tricky lang naman dito is yung nandito sa loob, this starts out as function I. If gawin ko tong, let's say, x squared, at the worst case, ito, let's say, so magiging O of I ito diba? So at the worst case, I is equal to x squared. So may x squared to. So x squared na siya dito pa lang sa loob. And then may x squared to, may x cubed to. But yeah, so given yung original function of x squared. And then dito is yun, may conditional lang. So since alam natin si function 2, x squared yung running time niya, and then si function 1, O of x lang siya. So at the worst case, itong function 2 yung mag-dominate. So hindi natin kailangan pansinin yung nasa, kahit hindi na natin pansinin yung nasa else na statement. So yung body ng loop is O of function 2 of I na we know na big O of so x squared. Pero I yung input, so I squared. And at the worst case, I x. So this is x squared. Now, if, for example, ito naging x squared din naman, itong I na to, at the worst case, magiging x squared. So maging big O of x to the fourth. Sa case na to. And then we'll multiply pa natin siya with the number of iterations, which is x squared. So O of x to the fourth multiplied by the number of iterations, maging x to the sixth. So actually, halos ganun lang din naman yung mga nandito. And then, nin-upload ko rin yung solution wherein may breakdown naman ng mga yung pag-compute. So, medyo nag-iiba lang minsan doon sa notations. So, hopefully masundan nyo pa rin. Kasi medyo wala namang ganun ka-standard. Lalo na for one-to-one purposes, hindi kami masyadong strict sa notations. So, as long as magkaintindihan tayo, that will be okay. So, that is yung first part ng week 2. Ang second part ng week 2 is yung sorting algorithms. And particularly yung n squared sorting algorithms kasi lahat sila yung running time nila is n squared. And so, sinend ko rin yung link sa Discord. You can go to visualgo.net/sorting/en/sorting for a animation ng sorting algorithms. So, for here, bubble sort, kino-compare niya basically yung magkakatabi. And then, if mas maliit yung nasa kaliwa, magsa-swap sila. So, you'll notice here, parang hinahanap natin yung largest element dito sa part na sa left side ng array. And nagbo-bubble up basically yung largest element sa dulo. Kaya siya bubble sort. Then you'll notice, meron tayong parang two parts doon sa array at any given moment. Yung colored part dito, wherein we're sure na sorted na yung array, and then yung gray part dito, which is yung unsorted part ng array. So, may dalawang loops dito. Yung inner loop natin, after each iteration, you'll notice dumadagdag by 1 yung elements doon sa sorted na list. So, kaya siya n squared. Yung inner for loop natin, dinadaanan niya lahat ng elements sa unsorted list. So, at the worst case, n items yun. And then yung outer loop naman natin, basically it just tells the computer to do yung inner for loop for a number of times. So at the worst case, isa-isa lang yung dumadagdag sa sorted. So at the worst case, we need n times or n times natin kailangan pasadahan yung loop. And then, so n times kailangan gawin yung sa loob. And then, inuulit natin siya n number of times. So n squared. So I think mayroong mas detailed na explanation doon sa lecture materials na binigay sa inyo. Again, so medyo supplementary lang naman to. If meron kayong mga questions or clarifications, just let me know. Sa selection sort naman, basically hinahanap natin yung minimum element doon sa grayed out na elements. And then once we found yung minimum element, ipapasok natin siya doon sa colored na list or yung sorted sub list natin dito on the left. So, ang ginagawa niya, you pick in order to find the minimum element sa isang list, kailangan natin check isa-isa yung elements. So, yung paghanap ng minimum is an O of n operation. And then, we need to get n minimum numbers para ma-complete yung sorted na list. So, total runtime is O of n squared. So, yeah, patapusin na natin ito. So, hinahanap yung minimum doon sa list. Now, for insertion sort, parang, you can say parang selection, parang selection pero actually hindi. Ang nangyayari sa insertion is basically nagbe-build ka ng sorted na array over here. And then when you get an element from the unsorted subarray, hinahanap hinahanap mo na yung tamang position ng i-insert mo. So in this case, yung i-insert ko dito is 36. It should go between 15 and 38. Then yung next element, 26, insert ko siya between 15 and 36. So basically, ayun lang naman yung algorithm niya. So the worst case, wala yan 2. Yung i-insert natin, kailangan natin i-insert sa dulo. So that at the worst case, that will take n number of comparisons. And then, so yung pag-insert natin will take n at worst, n number of comparisons, and then we need to insert n elements. So yung running time nito will be O of n squared. So, tapos na siya. And then, nandito rin yung mga other sorting algorithms. Yung merge sort, hindi pa siya ano ngayon, pero it's one of the faster ones. And then, si quicksort, siya yung isa sa mga widely used. Actually, ang quicksort, at the worst case, O of n squared siya. So, considered siya as an n squared sorting algorithm. Pero ang average case niya kasi would be log linear or n log n. So, ayun, siya yung usually used in practice. So, yun lang naman for sorting algorithms. So, ayun. You have two graded activities, yung quizzes na uploaded sa Drive. So, yeah, yun lang naman for this week. Actually, dapat medyo tapos na kayo. Medyo na-late ako eh. So, any questions ba from those here? Anything in particular? Kasi dalawa lang din naman kayo if may specific questions kayo. So kasama ba yung pag-print sa pagbilang ng big O? So, ang sagot is actually yes. Although, ang pag-print kasi is just a constant na operation. So usually, kuwari, dagdag up ng print dito. Magdadagdag lang siya ng O of 1. So, pag in-add natin yung dalawang O of 1 pa rin. So, medyo hindi siya ganun ka-important, I guess. Although kung print lang naman kasi yung ginagawa, siya na yung O of 1. So, ayun. Did I understand the question correctly?
So basically, O of 1 plus O of 1 equals O of 1.
Yeah,
One
so,
constant, another constant is another constant.
so yeah, sasama mo siya sa bilang, pero usually nakakain siya doon sa bilang. Example ng O of log n. Actually, ano siya? For of a future topic, pero pwede ko naman na i-preview yung actually sa topic ko. See. Usually pagdating na sa recursion or sa divide and conquer, wherein yung buong hindi natin tinitignan yung buong list. Actually, dito rin naman sa visual algo yun. I don't think may maganda akong animation dito. Meron ba? Hmm. I guess hindi masyado. Ito nga ba? Hindi ko pala dito. Mas dito pala. Kaya yung simple case na lang sa loops. Let's say gawin ko yung update ko is start siya sa 1 and then yung update ko is times equals 2. So essentially, yung iteration, sa first iteration, yung I natin would be equal to 1. Sa second iteration, I would be equal to 2. Third iteration, magiging 4. Fourth, magiging 8. Fifth, magiging 16. So, let's say x is equal to 17. Mag-iterate lang yung loop 5 times. If x equals 33, mag-iterate lang yung loop 6 times. So, ano yung relationship ni x doon sa number of iterations? So, pwede mong tignan, ito is equal to 2 to the 0. Ito is 2 to the 1. 2 to the 4. Okay? 2 to the 2. 2 to the 3. Okay? 2 to the 4. Okay? 2 to the 5. So basically, 2 to the number of iterations minus 1. So, to calculate, since ito yung magiging maximum value ni x, pwede mo itong equate sa x. So, given an x, ano yung number of iterations na makukuha mo? So, you'll get here is maging log base 2 of x, yung number of, approximately, yung number of iterations. So, since yung number of iterations ng loop na to is log base 2 of x, maging log of x to. Hindi lang siya plain x. So, maging O of log x. So, usually, ginagawa lang log para titipid sa letters. So, yeah. Basically, nagagamit yung ay nakakakuha ng log of n na time pagka nasa divide and conquer approach na. Kasi, as you can see here, dumodoble yung value ng I at each time. So, parang nakakalahati, mas mabilis tayong natatapos dun sa iteration than the number of x. So, yun. Or, kung gusto yung mas tamad na approach, pwede naman straight out na gawin ko lang itong log x. So, log of x na siya. So, yun yung medyo tamad na example. And then, yung medyo real life na example, kung ano binary search, hindi kasi, wala yata kasi akong magandang example. So, pag linear search kasi, check ko isa-isa yung items. So, pag linear search, start ako dito. Equal na ba ito doon sa hinahanap ko? No. So, go to the next. Then go to the next until mahanap ko yung item. Pero for binary search, at the worst case kasi yung linear search, dadaanan mo lahat eh. So, for binary search, instead of doing that, is magsa-start siya sa middle. Tapos, if higher or lower, pupunta siya sa baba or pupunta siya sa taas. And by doing that, kung going lower tayo sa binary search, basically, hindi na natin kailangan tignan yung nandito. So, nakalahati ko yung mga kailangan ko i-check. So, kaya siya naging log of n. Ayun. Okay. Meron pang ibang questions? Yeah, if maalala nyo na lang magtanong after nito, nandiyan ang Discord, emails. So, well, good luck sa week 2 activities. Hopefully sa week 3, okay na yun ulit. And then, tignan natin if kailangan natin mag-hold ng sessions ulit. Okay. Maraming salamat sa mga pumunta. And, ayun, kain na tayo. Lunch na.